Hi there, we're going to dive into the world of Windows desktop logon performance today using the Avacee Systems Intelligence Platform. Quick recap, the Avacee platform is a born-in-the-cloud, massively scalable, extensible way of managing IT systems no matter where they are. So let's dive in, look at the dashboard here, and as you can see, it gives us a view of recent logons, a range of different systems. Let's pick this one here and click on it and dive in. And this breakdown here is pretty unique. What you're seeing here is a really granular view of what happened during the logon process for this particular user. As you can see, they logged in a particular date and time, duration, we've got information about their domain controller, the profile type, redirected folders, group policies. We've got a view of the last 10 logon times, which would be on any system, not just this one, and their average experience. Then really uniquely, we have this timeline view that shows everything that happened for this user from the moment at which they authenticated, entered their username, password, and hit enter, and up to the point at which Explorer begins and the beginnings of a graphical interface. And you can see that took 27 seconds, and a contributing factor was the fact that the CPU is pegged at 100% for the entire time. You also get a view of the system disk queue length here, which is not too bad. It's busy, but it's not, permanently backed up. The user profile took 8 seconds to load. It's a roaming profile in this case. If you're seeing consistently long profile loading times, you might want to look at a profile management solution or alternative there. You can see the breakdown of the group policy load on here. So for every group policy client-side extension, you get a breakdown of the policies and how long that extension took to run and whether it succeeded or failed. These will run very quickly, but I'll show you a bad one in a moment. And then you see every process that happened, not just leading up to Explorer starting, but after, because the user may have complained about sluggish or poor desktop performance even after Explorer began. And so for every process, you get a lot of information. You get the process, its name, friendly name, the parent process, ID. You get the full command line that was used, resource consumption. And you can see that some processes were still running at the point at which we ended our analysis of the logon, but they continued into the session. In this case, it's a login script that's been triggered out of group policy. It's a group policy script. As you go down, you'll see other login scripts and other processes that began as part of the logon sequence. And down here, you see Chrome began very early in the logon process. Maybe it was auto-loaded homepage or something, and that launches a million processes, as you can see. Anyway, this gives you a breakdown of a logon here on a session host, and most things have worked pretty well. As you can see, it's busy, and the biggest problem here is the hardware. Clearly, you need some more CPU resource to make logins better for these users. Let's look now at a couple of bad ones. And to do that, I'm going to open up a list of all logon sessions from the list of reports that Avacee gives you. So this table view is very powerful, sortable, filterable, over thousands of rows in an instant. I'm going to look for one that I happen to know is pretty bad because the user called in and said something seemed strange or off about their desktop. Now let's go dive in and look at that. And I'm going to scroll down here, and the thing you're going to notice is this folder redirection, client-side extension. So whereas previously the group policies ran very quickly, this one's got a much longer bar. It took 2.5 seconds here and it threw an error. Now 2.5 seconds is not bad, but if there were multiple group policies looking for the same missing file share or server, then that can really stack up. The reason here is that one of these group policies is looking for a folder that doesn't exist. And you could dive in, you could find that exact group policy, and then you could update it to use a new file share or just get rid of it or use a different method. Okay, we're going to go and look for another session where the user complained of a different problem. I'm going to filter it down to this, and let's go and look at this particular session. What you're going to see here is interesting. The user is a physical desktop, first of all, no folder redirection, no group policies, local profile, generally very fast logons, but something was still up. When they logged in, they complained that things seemed slow to start with. You can see they logged on in 1.3 seconds. Everything's great there. But the disk queue, and oh, by the way, the CPU also is really not that high. It's busy, but there's plenty of capacity. The disk queue is just insane. 168, 12 is high, 24, What's going on with their desktop? Well, if you scroll down here, you'll see a few things. First of all, there's a lot of processes being launched as part of the Logon process, and these with the double asterisk next to them, these are being launched out of run keys in the registry. You can see there and there. If we go down a little further, we'll see the Sophos UI for antivirus kicking in, coming out of the 32-bit emulation part of the registry. There's a lot going on, but the real smoking gun for high disk usage is the Unreal gaming engine here. You'll see Fortnite kicking off. And somewhere back here, there's another process related to the Epic Games launcher. These immediately consume a lot of CPU time, a lot of memory. Okay, one more interesting logon to look at for you. If we filter down to this one, it was actually my logon to a particular system yesterday. Here we go. Now this is different again because you'll see the logon took a long time, 92 seconds. It started off really quickly. Group policy is not an issue, ran in 0.09 seconds, profile loaded instantly. But something very strange happened at that point because the rest of the logon didn't begin for another minute and a half. And something's really happening here. CPU's absolutely pegged and then just sort of went back to half capacity. It's the disk queue that's the giveaway. When you have this kind of consistent disk queue level, not spiking at a very high level, just sort of consistently flat like that, it points to a storage problem. And the fact there's this long pause suggests that actually it was doing recovery of some file system damage in that time. So another thing to look at, again, would be the event log or some kind of hardware diagnosis to make sure you understand what's going on with the storage, because this long gap between sections of the logon points to something more fundamentally wrong with the hardware on this machine. Two more things I want to wrap up with on the subject of Windows desktop performance. Let's look at the user profiles for a few users. This is my development environment, and as you can see, this particular profile here is pretty large. There's 28 gigabytes of data in my users John folder, and it breaks down into a lot of stuff in app data, some documents, downloads, and so on. You can see the real breakdown here. In this case, none of these folders are redirected, everything's local. It's not a performance issue because it loads very quickly. I've got a fast SSD. If I was considering moving a user like this into a virtual desktop environment, I could be very selective about what I move into that environment. Copying 13 gigabytes of data out of app data local may not go so well. That's pretty expensive if you're going to put that storage in a data center. So this can help you inform the kind of rules you use for moving and migrating users into a virtual desktop. Now these are virtual desktop users. As you can see, it's roaming. And let's take a look at this. Much smaller profiles, but something very strange has been going on here. The fact that the user has 20 temporary copies of their profile suggests that something's been happening, some kind of corruption or some problem there. But as you can see, it's a roaming profile. It's a v6 profile, but there's Windows, when it gets into a panic and the profile gets corrupted or broken, it loads a new copy. It's happened 20 times. It's pretty small. There's actually not an issue with centralized storage, but it does point to an issue with corruption at logoff. And finally, I just want to show you the extensibility of this, because the way that Avacee works, it's got a lot of scripts and it's very extensible, and it pulls together data from the endpoint in different ways. The agent gathers some information, and then it can be embellished and added to by other scripts or anything else you want to bring. So in particular, the logon script takes the data that comes out of the agent and adds to it by looking up things in the event log. And you could extend this and add more of your own if you're a real expert. And these scripts can all be triggered on different events. In this case, things like a regular interval will be set to 10 minutes every default, or you can actually trigger things on the logon itself or on process starting. Okay, if you wanted to edit this in a more friendly environment, you can copy and paste it into something like Visual Studio Code. You can test it, run it locally, and then when you're done, you can copy it back into Avacee, and it'll be deployed out to all endpoints, updated, and then you can collect data as part of the logon process. So I hope you enjoyed this little view of how we can use the Avacee Systems Intelligence Platform to dive into logon performance, diagnose problems and begin to troubleshoot them. Thanks for watching.